So the first step is to create a new family. Now I'm looking at the recent file screen here in Revit, and there's a link right here to create new families. And of course, I can go to the big R and choose new and then family as well. And it's going to take me to the new family select the template file folder. So in this folder, we're going to see a list of all the various family templates that are available to us. Because I chose new family, it takes me to the folder that contains all the model templates. If you watched the previous chapter rather, you saw that we were going into the annotations folder and that had annotation templates. So here we're seeing the model templates. Now what I usually like to do is this. If I select the first item in the list, don't double click it. If you double click it, you're going to create a new family from that template. But if you single click on it and then use the arrow keys on your keyboard, you can pretty rapidly scroll through each of the templates and get a preview over on the right-hand side. This is a way that you can quickly familiarize yourself with the various templates that are included in this folder. And without really spending too much time lingering on any one, what you start to notice is each of these templates contains very different things. Sometimes there's some text notes to describe what you're supposed to do. We, of course, recognize the two green reference planes marking the insertion point that we've seen previously, and in some cases, they even contain existing geometry. Now, you're going to see existing geometry included when the name says the word based in it. Now, the particular one that I have selected right now says specialty equipment wall-based. This is telling me that this family is a hosted template. We talked about that in the previous movie. This idea that we're choosing two things when we select our template. We're choosing the category, and we're also choosing the hosting behavior. Specialty equipment would be the category, and wall-based means that this particular item would require a wall host. If I want a non-hosted piece of specialty equipment, then I would choose this template instead. If we look at some of the other categories, like mechanical equipment, I see that there's actually two hosted versions. There's the ceiling-based mechanical equipment, there's the wall-based mechanical equipment, and then there's just simply mechanical equipment. What if you're not sure? How would you decide? Well, you can change your mind about the category later. You cannot change your mind about the hosting behavior. So the best thing to do if you're not sure whether you want it hosted or not is to choose the non-hosted version. Every category that you see here has a non-hosted version, so you can always choose that to play it safe. You can always take a lighting fixture that's set up as non-hosted and move it next to a wall and align it and lock it. So you always have the ability to make it kind of look like it's hosted, but you can't take something that's hosted and pull it off the wall. Okay, so that's not allowed. Now, in our case, it's a little simpler because I said we're going to create a conference table. And what you notice here is there's only one furniture template, and it's not hosted. So there really isn't any such thing as hosted furniture. Even though you might be tempted to say, well, furniture should be hosted to the floor, that's sort of assumed and obvious in Revit. So every object has an association with its parent level. That's not really considered hosted per se. So in this case, we're going to choose the furniture template, and we're going to click open. And when we do, you kind of saw things flash by a little bit. And the reason for that is if I do the keyboard shortcut for window tile, which is WT, you're going to see that there's actually 4 open windows here. Now, if you don't like keyboard shortcuts, I could have gone to the View tab and chosen the tile button here and would have achieved the same thing. Now, the other keyboard shortcut I'm going to do is ZA, and I'm going to zoom all the viewports to fill the screen. Now, at the moment, the 3D view won't do that. It's not going to do that until I get some geometry in there. We can see that the template starts off with these 4 open windows. We have a floor plan, we have 2 elevations, and we have a 3D view. And that's going to be helpful while we're working because as we're making changes in one view, we're going to see those changes and how they respond in the other view. And when you're working on 3D geometry, that's really helpful. The next step in the process was to begin laying out the structure. Before we do that, let's talk about the ones that are already here. This one right here, there's a reference plane going horizontally, and if I hover over it, you see it's got a name called center front back. And if I hover over this one, it's got a name that's called center left right. Now, hover over it, you can see it on a tooltip. If you click on it, that name actually appears as a blue label. The other thing you're going to see is that these 2 default reference planes are pinged. They've done this because if you recall from our annotation family exercises, the 2 reference planes in the center mark the insertion point. So if you pin them, it means that people won't be able to accidentally move them, and that's kind of a good thing if we want that to be our insertion point. But what makes that the insertion point is if I select on it, you can see that reference plane is actually set to define the origin. So both of these reference planes, if I click on them, have that defines origin checkbox checked already. This is in the default template. I haven't made any changes yet. This is already all here. So that's what we're starting with, and we're not really starting with much else. Let's go ahead and save this. Save it as a family. And I'm just going to call this simple conference table. I mentioned this in the annotation family movies. I like to do the same thing with my model families. I'm going to click on options, set the backups to 1. In annotation families, I didn't have to worry about the preview because it was only a single view. But here in model families, there's an option down here to set the source of the preview file. Now, the default is just the active viewer sheet. What I'm going to do is open that up and change that to the 3D view. Now, there may be more than one 3D view. I can choose any one that I want. And then if you check this box, it just regenerates. It doesn't really matter in this case because there's no geometry, so that's not really going to help me very much. But I want to make sure that I have one backup and the 3D view is the source of my preview, and then I'll go ahead and save this. So that gets us started. So here we've created our family file, we've set up our work environment, and the next step is going to be to start laying down the reference planes that'll serve as the framework for the family. In project files, we establish the overall form and structure of the building with a series of levels and column grids. Not every building has column grids, but many of them do. Such data elements are not available in the family editor. All model families do include 1 or 2 reference levels. It really depends on the actual template you start, whether you'll get 1 or 2. In the family editor, instead, we use reference planes. Reference planes are what are going to determine the overall structure and form of our family. We started with the 2 here in the center, and what we're going to do here in this movie is we're going to add additional ones to represent the overall shape and size of our table that we're drawing. So to do that, I'm going to start here in floor plan, and I want to draw a series of 4 reference planes to represent the 4 sides of the table. I'm going to go to my Home tab, and there are actually reference lines and reference planes. I want you to make sure that you're choosing reference planes. We will discuss reference lines in a later chapter. When you choose reference plane, there's 2 ways to draw them. You can either draw them point by point or by picking other geometry. Choice is really up to you, but I usually just draw these point by point. I'm going to start here above my existing reference plane and just draw horizontally across the top. Now I usually like to click the dimension and set that to some rational value, like maybe about 2 feet here. I'm going to draw another one, coming vertically this way, rationalize that value, and then I'll click my modify tool to get out of there. Now, this is a little fussy thing that I like to do. I usually like to adjust the lengths of these things a little bit and let me mirror them to the other side, and I'll talk about why I like to adjust the lengths of those. So I'm going to select this one, mirror it around the center, select this one, and mirror it around the center. I'm going to temporarily maximize this floor plan and zoom in on it. What we can't do in the family editor is change the color or line type or anything like that of individual reference planes. I could change all the reference planes, but that really wouldn't serve the purpose that I'm looking for. What I'm looking for is some sort of visual hierarchy on the screen. So if I leave the overall center reference planes longer and take the ones that I'm drawing and maybe make them a little shorter, but make them match one another, you see how they kind of snap here? This is a way that I can establish this visual hierarchy on screen, even though what I'd really like to be doing here is changing the color or the line type of these things. So this may seem like a little fussy step, and it's certainly not required. I don't want you to think that you have to do that. But personally, I like to do that because I think that gives me a little bit of visual hierarchy. And at the moment, we've only got 4 reference planes. But as we start getting dozens of them, you're going to appreciate having some way to be able to quickly identify them. Now, the other thing you can do is you can name them, and we'll get to that a little bit later. But that's another way that you can help to identify them on screen. So I've got the 4, and that gives me the overall basic footprint of the table. The next thing I'm going to do is add some dimensions. I need 4 dimensions. I want one that goes from the left side to the center to the right, and I'm going to make that equal. We do another one here. It's kind of the same from top to center to bottom. Make that one equal as well. And then I want two overalls. One that gives me the overall width and another that gives me the overall height. And I'll place each of those and then click my modify tool. At the moment, what I have is this dimension is actually now a constraint. And this one is just a dimension. It's not anything yet. So what I mean by that is if I took one of these reference planes and I dragged it either to the left or to the right, doesn't really matter which way I go, you're going to see that the other one on the opposite side is going to move the same amount. I'm going to undo that with Control Z, and that's because of the equal equal. That's what we refer to as a constraint. We're constraining the position of the two outside reference planes so that they have to be equal relative to the center. What I want to do next is take the two outside dimensions and turn those into what we call a parameter. A parameter is going to be a value that my end user is going to be able to type something into. So this is going to be the length of my table. This is going to be the width of my table. And I want to make both of those values editable values that the end user can manipulate. So we do that by making those into parameters. And the way we do that is a pretty simple process. I go ahead and select the overall dimension here. And we're starting to see some common terminology that we've seen elsewhere in the family editor. If you recall from the annotation families, we were able to add labels, which were intelligent pieces of text that were linked to some parameter in the object. We can now label dimensions. And when we label dimensions, we will have a choice here where we can add a parameter. And what we're going to be doing in this case is giving this dimension a label. In this case, I'm going to call that length. I can make it either a type or instance. I'm going to leave it type for now. We'll talk about instance parameters a little bit later. We'll accept the default for now. And when I click OK here, what you're going to see is that length is going to be applied in front of the dimension. That is now a parameter. It's a driving value. That value, length, is actually driving the size of the dimension. Now let's go ahead and label this one, and I'll illustrate what I mean by that driving behavior. We call this width. Accept all the defaults, click OK, and I now have it labeled here and here. The next step in the process is to do what we call flexing. Flex is where you test out your flexible parameters and make sure that they're working the way you expect. How do we do that? We come up here to the Properties panel, and we click the Family Types button. When I click that button, I get this dialog. I'm going to move it out of the way a little bit. Each of these parameters corresponds to the two dimensions. Here's the width. You can see it highlight over here on the left-hand side. Here's the length. You can see it highlight up here at the top. So if you've lost track of which parameter belongs to which dimension, you can just simply select it. And then here in the value field, I can try another value. So I'm going to try 3 feet for the width and maybe 7 feet for the length. And when I come down here and click apply, you're going to see both of those values adjust. And this is what I meant by those parameters are now driving the value of that dimension. And in turn, they are moving the corresponding reference planes as a consequence. So I'm going to go ahead and change these values back. I always like to change them back to my starting values. I like to think of these as my home values. Click apply. Everything readjusts back the way that it started. And I'll go ahead and click OK. And that's what we mean by flexing the model. It's a good idea after each iteration in your family to go in and do a flex to make sure everything is working the way that you expect. It's going to be very difficult, if not impossible, to track down a problem if you set up a couple dozen reference planes, a couple dozen parameters, then go to family types, change all the values, and the whole thing fails and breaks on you, and you'll have no idea which parameter is actually causing the problem. So this is why we recommend frequent flexing of your model in order to make sure that everything is working correctly. So this gives us our basic formwork and our structure for our new family. As you can see, we can add reference planes, label and constrain them to give them a little bit more smarts and intelligence. In the next movie, we will begin adding geometry to the family and attaching that geometry to this formwork of our reference planes. So we've created a new family. We've established its category, laid down the reference planes, even applied some parameters and constraints. So now we're finally ready to actually start modeling something. We're going to add some geometry, and the first form that we're going to look at is just a simple extrusion. Now, we do have the opportunity in the next chapter to get into detail on all of the various forms. I'll just point out a few of them to you right now. Here on the Home tab, there's extrusions, blends, revolves. You can see there's actually 5 forms, and then the same 5 forms are also available under voids. The simplest of the 5 is the extrusion, and that's the one we'll start with now. Just a little sidebar, if you pause your mouse over any of the tools, as you've no doubt discovered in the project environment, you get tooltips. You get the same here. This helps you identify what each of the forms look like. So we can see that this is actually going to be a sketch-based object. We've encountered other sketch-based objects in the project environment, most likely, if you've been working in Revit for a while. You've seen floor objects or roof objects or stair objects. Extrusions and other solid forms are very similar. They take you into sketch mode, and as you can see, the drawing has grayed out here in the background, so that's one of the obvious indications that we're in sketch mode. The next thing that's fairly obvious is the ribbon tab, tints and color. So it says modify, create extrusion here on the ribbon tab, and the whole thing tints in this sort of greenish color. The last indicator that you're in sketch mode is these 2 icons right here. So we get a mode panel, we get the big green checkbox, that's our finish edit mode, and we get the red X, that's our cancel edit mode. We use either of these buttons to complete the sketch mode and move on into something else. You do have to finish the sketch mode before you can move on to some other task. So you either have to complete it or cancel it. Now, I should just say that a common mistake for beginners is to start off sketching something and then get sidetracked and go click onto one of the other ribbon tabs. If you find yourself doing that, what you're going to see is that it doesn't look like you can do anything. A lot of things are going to be grayed out. You're going to see everything's grayed out here. You really need to stay on this Modify Create Extrusion tab. It's very important that you do that when you're in sketch mode. So look for the tinted colored tab and stay there. Everything you need to draw your extrusion is on this tab. So I'm going to start with a rectangle. I draw a simple rectangle form, and I want to snap that rectangle to the opposite corners of these reference planes. Now Revit will offer to lock that sketch to the underlying reference planes. And normally that's a really good thing for us to do. It actually applies a nice constraint. It keeps the shape constrained to those reference planes. And ultimately that is what I'm going to want to do here. At the moment though, I'm going to actually not do that. And I want to show you what will happen if you choose not to. So I'm just going to go ahead and draw the sketch and click the big green checkbox and finish that. So when I do, you can kind of see that here's the form right here. A little tough to see in plan, so I might want to shift over to other views to get a look at it. But before I do that, I'm going to stay here to look at this. So here's the form right here, and it is attached to these reference planes. Let's go ahead and flex it. I'm going to go to my family types dialog that we've seen before, move it out of the way, put in a number here, put in another number here. Doesn't matter what numbers I put in really, and click apply. You may be a little surprised to see that the form actually adjusts, even though we didn't constrain the sketch, right? We did not click the little padlock icons, and the sketch, therefore, was not locked to the reference planes, but yet somehow Revit is assuming that we want that behavior anyway. Why is it doing that? Where is that assumption coming from? I'd like to talk about a concept called automatic sketch dimensions. While you're creating items in Revit, Revit is always looking for opportunities to add smarts to those items, to add relationships, and to make the overall experience more intelligent, more valuable. In this case, it's doing that with something called automatic sketch dimensions. You have to kind of know that these things exist in order to understand that they're there and to make use of them. I'm going to show them to you in the visibility graphics dialog, and I'm going to use the keyboard shortcut to get in here, VG. So if you type the letters VG in succession, that will take you to the visibility graphics override dialog. If you've gone into this dialog in the project environment, you see a lot more categories listed here than what we're seeing right now. Because we're in the family editor, I'm only seeing the active category, furniture in this case. There's really no clue here to automatic sketch dimensions in this case because everything is turned on. If you go to the annotation categories tab, under these dimensions, there is an item called automatic sketch dimensions, and by default it's turned off. So I'm going to go ahead and turn this on, click OK, select my extrusion, and edit the sketch. Now when I do that, you're going to see these four tiny little dimensions that are set to 0 appearing on each of the four sides of the sketch. You can leave these if they're giving you what you want. You can use them just fine. There's really no reason otherwise. But sometimes the automatic sketch dimensions will actually start to give you results you weren't looking for, usually when the forms get more complicated. So we'll probably have some opportunities to discuss them again in later movies when the forms start to get more complicated. If you decide that you want to be more deliberate about where the constraints are and what's controlling what, and this is really the point of the discussion, then you can assign the constraints yourself deliberately, and when you do, that will remove the automatic sketch dimension. In other words, you can't have both an automatic sketch dimension and a manually applied constraint. The manually applied constraint will always override and remove the automatic sketch dimension. I can't just delete it. If I try and delete it, it just comes back. So the delete key isn't the answer. What we want to do is take this geometry and lock it to the underlying reference planes. Now we can do that one of two ways. I could move it out of the way and then move it back again to get the lock to appear. When I click that, notice that the 0 dimension disappears. Or the easier way to do this is with the align tool. So I'm going to click on align, click on the reference plane, and then the sketch edge and lock it. Click on the reference plane, sketch edge, and lock it. Notice the dimensions are disappearing when I do that. Click on the reference plane, sketch edge, and lock it. So all four automatic sketch dimensions disappear. I go to finish, and ultimately I really won't see anything different with respect to how it flexes. It's still going to flex the same way, but that's only because the geometry that we have on screen is so simple. Later, when the model gets more complicated, you're probably going to find that you're going to want to control those constraints a little bit more deliberately than relying simply on the automatic sketch dimensions. Wanted you to be aware that they were there and understand how they behave. The automatic sketch dimensions will apply automatically by the software and will remain around until you apply other constraints manually to override them, and then they will remove. But before you can, even though they're there, you have to go to VG and turn them on. So that's creating our first piece of geometry and a little bit about how it gets constrained to the reference planes using automatic sketch dimensions. As we continue in our first model family, and if we begin to study it carefully, we're going to realize that the extrusion that we've modeled, which represents our tabletop, is actually sitting on the floor and it's very thick. In this movie, we'll adjust the height parameters of our table model, and we'll introduce the concept of work planes to help us understand ways that we can control that height parametrically. I'm still here in the floor plan view, and I have my basic table model as we continue. What I'm going to do is press WT again, and I'll do ZA to zoom everything to fit. And first thing I want to address just quickly here is when I'm working in tiled views, it might be a little difficult to read the dimensions, because the scale of this view is set to 1/2 inch equals a foot. That's just in the default template that we use. Now, we're not going to print from our family editor, so really the scale is kind of irrelevant. So what you can do here is anytime you want to make a view more legible, you can just change the scale, and that will have an impact on all the annotations. So in this case, I actually want to make the text a little larger, so I'm going to switch to 1/4 inch scale and then zoom in a touch. And I can do the same thing in these other views as well. So I can go in here and make this one 1/4 inch. Make this one 1/4 inch. I don't really have to worry about that here in the 3D because there's no annotation here. However, in the 3D, I'm looking at it edge on right now. So if I use my little view cube here and click the corner, I can get it to zoom to a 3D view, maybe adjust the vantage point a little. And it's looking pretty hollow right now because it's set to wireframe. So I'm going to change that to shaded. We already saw this in the plan view, but now we can see it very clearly that what we really have is this very thick slab sitting down here on the floor. So for the next couple steps, I'm going to work in the elevation views to establish the height of our table. So the first thing I want to do is work here in the front view. What you're seeing here, both right and left, here in the front view actually are the two reference planes that I drew here in the floor plan. So if I select this reference plane, you see it also highlights here. I select this reference plane on the left, it also highlights here. Likewise, if I select these, you can see them highlighted in the right view, both the front and the back. So what a reference plane actually is literally it's a plane, and if you think of it as a thin little sheet of paper standing upright in this model, that's a pretty good indication of what you're seeing. You're looking at the edge of that sheet of paper at any given time. So what I want to do here is create first a new set of reference planes. So I'm going to go back to home, and this is somewhat review, so I'm going to do this fairly quickly here. Just add a reference plane, set the dimension to 3 feet, which seems like a pretty good height. Then I'm going to add a second reference plane directly below it and set the distance between these two to 2 inches. It's just a more rational number. So I want ultimately my tabletop thickness to be 2 inches thick. So I do that by establishing a couple of reference planes. Now at the moment, these two are completely independent from one another. So if I move one, the other one gets left behind. I'm going to undo that. So what I want to do next is set up some parameters and some constraints to control the behavior of these two reference planes. Dimension between the two reference planes first, and click over here somewhere. And what I'm going to do is simply close this little padlock. Now, if I escape out of there and move one of these reference planes, the result of that is that those two reference planes are now locked together. That's another form of constraint. So earlier we talked about equal being a constraint in the plan view. This is another form of constraint. We're now moving one reference plane and having it move the other. I can give you another definition for the difference between constraints and parameters. I keep using both of those words, but I want to make it clear here what I mean by the difference between that. When I talk about constraining something, I'm establishing a rule that cannot be changed by the end user of this family. So by blocking this 2-inch thickness, they're not going to have a checkbox or a text field or a dimension that they can input a value in to change the thickness of this table. That thickness is going to be maintained as 2 inches. Likewise here, with the equal, there's not going to be a setting anywhere in this family where the user is going to be able to change that in some way so that it doesn't have to be equal, so it can be unequal. That's what we mean by a constraint. A parameter, on the other hand, width and length in this case, or the new one that I'm going to establish from here down to here for height, that is something that my end user is going to be able to manipulate and make a change to. So that's what we mean by a parameter. I've selected this first reference plane as the first witness line of this dimension, and I want to be very careful down here. If you move your mouse around down here, it turns out that if you're underneath the extrusion itself, there's actually 3 objects there that I could highlight. And if I'm over here off to the side, there's 2. I'm going to go directly underneath the extrusion and show you the 3 objects. Same way that you toggle between objects in the project environment, you would do in the family editor. You'd use your tab key. So I'm going to press tab here, and I want you to watch the status bar right below my project browser as I do this. So currently the status bar says extrusion : shape handle. So then I'm going to press the tab key. And you'll see next it says levels, level, reference level. So it's a lot of words, but it's basically telling me that it's highlighting the reference level. And if I tab one more time, what we see is there's actually a reference plane also in that location. And if I tab a 4th time, it'll just go back to the underside of the extrusion. You definitely do not want to attach the dimension directly to the geometry. In certain circumstances, the reference plane is okay. But in this case, what we really want is to attach it to the level. We want the height of the table to be referenced from the floor level. So it's going to be really important that the floor level is what's highlighted before we click and create that dimension. So you have to be very deliberate about the work you do in the family editor. If you don't, you will be sorry later because things will break and fail. So that's one of the key things to look out for is exactly what are you attaching that dimension to. Okay, so in this case, we want it to go from the level to the upper reference plane. Once I have that dimension, I can select it, and just like we did before, I can label it. I don't want to choose one of the existing parameters. I want to add a new one, and I'm going to call this new one height. Now we'll talk a little bit more detailed about the difference between type and instance parameters in a later movie. But for now, I am going to set this as an instance parameter, and I want to just say it this way. Think about a type parameter as a parameter that represents something that is going to be built in the factory to a certain specification. So this table is going to come from the catalog is either a 4-foot size or a 5-foot size. It's going to become a certain width and length. The height, however, I'm going to set as an instance parameter. And what I'm basically saying is my end user will be able to adjust some sort of a ratchet or some other hardware on the legs of this table and adjust the height of the table. So we're making that an instance parameter. In other words, each instance of this table will be able to be a different height, but each width and length will actually be controlled as a group. So if you change the length of one table, you could potentially be changing the length of dozens of tables, but if you change the height of one table, you'll only be affecting the one you select. That's the difference between type or instance parameters. And you can do this with any parameter. And I always like to take my cues from this sort of product catalog that I'm thinking of. So in this case, I'm building presumably a real product. So I would think about the product catalog and how it comes from the factory in reality and try and build it as close to that as possible. So I now have my height. Let's go ahead and flex that. I go to the family types again and kind of move this out of the way a little bit. Here's my height parameter. You will see the word default now in parentheses. That's how you know that you have an instance parameter here. And if I make an adjustment, you'll see it move down and it takes the 2-inch reference plane with it. Let's make it really tall. Takes the 2-inch reference plane with it. And let's set it back to 3 feet. So there's our framework. Now at the moment, all we've done is added some more reference planes, added some more dimensions. We haven't done anything with the geometry. What I really want to happen is this slab here, instead of being 1 foot thick as it is right now, I want it to be sandwiched between these two reference planes. So we've set up the various height parameters now. We've got it all flexing and working the way that we expect. But what we still need to do is take this piece of geometry here and get it sandwiched between these two reference planes. And that will be the subject of our next movie. We create our sketch-based geometry in Revit. We need to create that sketch on a plane. If we don't establish a plane to do that ahead of time, then Revit assumes one, and it usually uses one of the defaults, either the level of the project or one of the intersecting reference planes at the center of our family here. What we can do is establish an alternate work plane elsewhere in 3D space, and then we can create our sketch-based geometry on that work plane. The workflow can be to either establish the work plane first and then draw the geometry, or in the case where we have here, where we've already drawn the geometry, it's actually possible for us to establish the work plane after the fact and then move the geometry to that work plane. So we're going to go ahead and take a look at that process here in this file that we have on screen. So when we left off in the previous movie, we had identified that the slab was sitting on the floor and we had set up these height reference planes to get us started establishing the height of the table. I would like to point out a slight difference in the reference planes that were already here in the template and the ones that we drew. So if you recall from the start of the exercise or any of the family templates that you may have previously been in, when you select them, there's a couple key settings that we looked at early in this chapter. One of those settings was the push pin. One of those settings was that it defines origin. But we also pointed out that there was a name or a label on that reference plane. It turns out that the key to using a reference plane as a work plane is the named label. In other words, if we look at the reference planes that we drew previously here in this exercise, you'll see that none of them highlight with a label. As such, if I tried to select this geometry and use this button here and choose Edit Work Plane, what we would see is that there are no choices other than the existing reference level, which it turns out, if you look at my 3D view there in the background, is the current work plane of this solid geometry, and it's the only choice. If I would rather have the work plane be associated with either this or this reference plane, what I need to do first is simply name those reference planes. As soon as I name that reference plane, it will become eligible to be a work plane, not only for the existing geometry that I've already drawn, but for any future geometry that I would like to draw there. If I simply select this reference plane, come over here to the Properties palette, I'll notice that there's a name parameter and it's currently empty. I can type anything I want in here. The name is not important, just that it has one. I like to use descriptive names. So I'm going to call this underside. Press enter to accept that and apply it. And you're going to see the label underside appear on that reference plane now in views where it's selected. Once I do that, I can return to selecting the geometry, click on the Edit Work Plane button, and when I open this list, I'll now have that additional choice there. Choose that, and the geometry will jump up to that new height. So that solves half of our problem. We still have a slab that's too thick, but you can see the effect of the work plane. So by changing the work plane, the plane upon which this extrusion is sketched is now moved up to that new location. And I'm saying it that way because if I click Edit Extrusion, what you're going to see here is that if I switch to another view, notice that the sketch is actually up here. You see the purple line here, you see the purple line here, and here in 3D, the sketch is actually moved up to that plane. So it didn't simply just move the geometry, leave the sketch behind. It actually moved the sketch up to that plane, and that had the effect on the geometry when you cancel out of there. Now to change the height, it turns out it's pretty simple. All we have to do is use this little grip right here, stretch that down, and I can snap it and lock it to the reference plane up above. It doesn't really require that I name that, but I might want to name it. If I choose this and call it topside, now later, if I want, I can actually draw something else on that work surface, on the top of this conference table. For example, if there was going to be some sort of a little cutout, or there was going to be some sort of a little keystone that has power and so forth in the middle of the conference table, what I could do is click over to an appropriate view, like this floor plan, and I can go to the Home tab, and I can set the work plane. So now that I've created a named reference plane, I can choose this button, open up the list, and it may be a little difficult to see here in the 3D view beyond, but currently the floor is being highlighted. And you can see it also here in the right view in blue here that the floor is being highlighted. And I can choose this, open it up, and I can choose the top side, and you'll see that blue plane jumps up above, and it's a little more clear here in the right view. You can see the blue line coincides with the top edge of the work plane there. Click OK. And now if I created a new extrusion, say right here, and I'm just going to sort of eyeball the size of this thing and click Finish. It's awfully tall. I could adjust that. The right way to adjust that, of course, would be to create a new reference plane, constrain that reference plane, and attach the top edge of that. But as you can see, you can create the work plane first and then draw the geometry, or you can draw the geometry and then say, oops, I need to put that on a certain work plane and move it to the other work plane. I will say, however, though, the before or after only works if they're parallel. So in other words, I could not take this box that I've just drawn on the top of the table, choose Edit Work Plane, and move it to the vertical work planes. Notice how there's only 3 choices here? If I cancel out of here, and I go back to Home and choose the Set button, notice there's far more than the 3 choices. We also have the center front back and the center left right. And if I choose that, it actually makes the vertical work plane active. So you get more flexibility if you set the work plane first and then draw the geometry, and we'll do that in the next movie. So up till now, we've kept the forms of our family pretty simple. We've used some basic extrusions. We could continue to use extrusions and create some support for our table because it's kind of floating right now. And we could easily conceive of some leg or support structure that was made out of simple extrusions, but we do have other shapes that we can choose from as well. We have blends, we have revolves. So we could really conceive of legs or other support structure for this table using really any of those forms. Furthermore, we discussed work planes in the previous movie, and we saw the impact that that would have on not only the existing geometry that we already drew, but any future geometry we created. What I'd like to do is take both of those concepts and kind of bring them together here to kind of reinforce both of those, give us an opportunity to look at another kind of form, in this case a revolve, and some additional work planes, and use that to create the support structure for this table. In a way, this movie here is going to actually wrap up and summarize everything we've been talking about so far to create this 3D form and just sort of reinforce all of the various concepts. So I'm going to start actually in the floor plan. And on the Home tab, I'm going to create 4 new reference planes. And those are going to be out at the edges. And I'm going to set them 4 inches off of the sides. So I'm just drawing them, changing the dimension. Cancel out of there, mirror it to the other side, and mirror it to the other side. So pretty much more of the same. You could name all of these if you wanted to. I really only need to name 2 of them. So I have to decide which one of them I want to draw my legs on. In this case, I'm going to draw in the right-hand view. And so therefore, I need to identify the reference planes that are parallel to that view. So if you imagine standing over here and looking at the model, we would be looking right at this reference plane and this other one that I drew over here. So those are the 2 that I'm going to name. So I'm going to name this one right legs. I'll apply that, and I'll name this one left legs, and apply that. Now, if I flexed, what we would find is, and I'll just flex in one dimension here, I'll just flex the length, that at the moment my reference planes are totally oblivious to the flexing. So I'll reset this back to 6, click OK. And what I need to do now is establish how I want those legs to follow the table. So I'm going to go ahead and add some dimensions. And I want to really stress here, if I zoom in and make this clear, I am not dimensioning to the extrusion. We pointed this out in a previous movie, but I think it's worth repeating. If your cursor is here, you need to press Tab to get to the underlying reference plane. So I want to go reference plane to reference plane. And this is one of the other reasons why it's a good idea to fiddle with the lengths of these reference planes. And you'll notice that I always make them a little longer than the geometry. This makes it really easy to highlight them out here without having to use the Tab key over here. Okay, so that's just another little tip that you'll find is very helpful. Now, these 4 dimensions, I could either lock them. If I wanted the offset to always be 4 inches, I could just click the little padlock and lock them, or I can constrain them with a parameter. I'm going to choose a parameter in this case. So I'm going to go ahead and choose Add Parameter, and notice that I actually used my Control key and selected all 4 at once. And I'm going to call this Leg Inset. I like to mix my case there. I'm going to leave that a type parameter, but again, you could think about this if the legs were mountable in different locations, then we could make it an instance parameter and the end user of the table could decide which location to mount the legs on if they were assembling this piece of furniture themselves. But if it comes from the factory with a certain inset, then we would choose a type parameter. And you'll see that all 4 of those dimensions get labeled with the same dimension. So at this point, if we flex, now you're going to see our new reference planes are going to follow along with the length of the table or the width of the table. And if I change the inset, maybe I'll do something a little larger and apply it, you're going to see it change all the way around. So let me reset all these back to my home values. And I just want to remind you that this is not required. It's just my little habit that I'm in. I always like to reset to the home values. So that's all my framework. I'm now ready to actually draw my legs. What I'm going to do differently from the tabletop is rather than draw the legs first and then move them to the reference plane, I'm going to go to a view where I can work in, like my right-hand view. I'm going to go ahead and make this just a little larger and zoom in a touch so I can see a little bit better here. So to set the work plane, I'll go back to the Home tab. On the work plane panel, I'll click the Set button. And what you'll see is that if I don't choose to set it to anything else, then Revit just assumes a default. And in this case, it's chosen the center, left, right. I can see that highlighted here in the 3D view, and I can see it as a blue line here in the other views because I'm looking at the edge of it. I don't see it in the right view because I'm looking right at the work plane, so you don't actually get an indication there. If I open up this list, you will see all of the reference planes that we've previously named, and that includes our left legs and our right legs. So I'm going to choose the right legs. That'll be confirmed in the 3D view as that plane moves forward closer to me. I'll click OK, and now I'm actually working on that work plane. So now I can go to the form that I want to draw. In this case, I want to draw the revolve. Now a revolve takes a shape, any shape that I want to draw, and it spins it around an axis. So I'm actually going to have to sketch two forms. I'm going to have to sketch the shape that I want to revolve, and then the axis upon which I want it to revolve around. And it'll be a sketch mode process just like we did before. So think of it like you're turning the leg on a lathe. That's basically what we're simulating here. I'm going to go ahead and click on revolve. That takes me to sketch mode like we saw earlier. Everything grays out. I get the tinted color sketch panel. I get the mode buttons and so on. Over here, I see two buttons. I've got the boundary line and the axis line. And I've got all my shapes. So I'm going to keep this one pretty simple. I'm just going to use lines. And I'm going to start with my boundary line. You need to just draw half of the leg. So I'm going to draw right down the middle here. Come over a little bit to the right. Come over a little bit to the left. Move up slightly. I'll zoom in just a touch. Give it a little taper at the bottom. Come straight up. Give it a little bit of taper at the top. Come straight up again. Could even angle back if I want to. And complete at a point. Now, before I move on to the axis line, I want to point out that we're seeing the sketch in all four views, and we're just seeing it from different vantage points. So if you look at the front view, you're seeing a long vertical line, which is the edge of the sketch. If you look at the plan view, you're seeing a really tiny purple line. That's the top edge of the sketch. And then, of course, we can see it best in the 3D view over here because we're seeing the entire sketch over here. So I'm done drawing my shape, and I'm going to switch over to the axis line button next. Now, there's two buttons here. You can either draw the axis line point to point, or you could use pick axis. And for a while, I used to use the pick axis pretty routinely because it allows you to select the reference plane, and that's kind of handy. And it will create an axis that matches the full length of the reference plane. And, if I deselect it, it looks like that. However, I'm going to undo that. What I've started to do recently is it occurred to me that if I go to the axis line and actually draw it, I can draw it up here somewhere, kind of out of the way, away from the sketch, and deselect that, and you see it kind of floating up here. It doesn't matter how long the axis line is. It's not the length that's important. What's important is the location of it and the angle that it implies. So in this case, by drawing a vertical line that coincides with the edge of my sketch, I'm going to spin my sketch on itself, and I end up creating a solid leg. If you looked at the tooltip of the revolve earlier when we highlighted on the Home tab, you may have noticed that they were showing more of a donut shape. So if I took this blue line and I moved it over here somewhere, I would actually get a hollowed out shape. So you can actually create a revolve that is either solid or more of a donut. In this case, I'm going to get a solid because it's drawn right on here. So there's a little tip for you that if you draw the sketch line off to the side, I find it a little easier later when I want to edit the revolve, because I don't have to use my tab key to try and highlight it, and it's just a little easier to get to. So I'm going to go ahead and click Finish here. And that's going to spin that shape around that axis. You can see that I've got the solid form. It's probably easiest to see over here in 3D. In any view, I can keep it selected, go to the mirror, and then mirror it around this axis. So that gives me two legs over here. Then probably the top view is the best choice for this. I'm going to select both legs, go to mirror, and mirror it this way so that I get the four legs in that view. Now, if I take a look at this thing in 3D, you'll see I've got all four legs here. It's shaping up pretty nicely. Let's go ahead and flex it and see how we did. So I'm going to go to Family Types, and I'm going to flex the length, click Apply. And what you're going to see is that it works great on the right-hand side, but the left-hand side is failing. So that clearly tells us we did something wrong. So discovering one problem, we might as well flex it in the other direction just to make sure. And you'll see in that direction, it's not a problem. So the problem only exists in the length. So what is the issue? Let's go ahead and reset it back and we'll talk about that. So the issue is that these two legs on this side are correctly associated with this named reference plane, right legs. So here's the named reference plane, right legs. And if you look carefully at either this guy or this guy, what you see is they have this little symbol on them. Now don't click that symbol because if I highlight over it, what you see is clicking it would actually disassociate the work plane. But the presence of that icon tells me that I have a work plane association. The other way I can tell that I have a work plane association is with the object selected. Over here on the properties palette, I can see the work plane item in gray. And then right here, it tells me that that's reference plane right legs. Now let's compare that to one of the legs on the left-hand side. I could select either one. I'm going to see that that little icon is not there. There's no disassociate icon. And the reason there's no disassociate icon is because the work plane is already non-associated. When we mirrored to the other side, it lost its association to the work plane. Pretty easy to fix though. All we have to do is select both of them, go to Edit Work Plane, and instead of not associated, we can choose left legs. Click OK. And now if we flex the family, click the length, and click Apply, you're going to see that it properly flexes. So I'll go ahead and reset this back. Click OK. And the best test of the family would be to actually load it into a project right now. Now, I don't currently have a sandbox project loaded, so I'm going to actually skip that step. I'll leave that to you to do on your own. But I do highly recommend that every so often you load the family directly into a project and test it out in that environment, make sure it's working. We're going to continue to work with this family in future chapters and add more features to it. So at that time, I'll actually load it into a sandbox project and test it out that way. So we'll save that for later movies. But at the moment, the basic geometry of our simple table is complete. We've explored many of the steps that are required in the basic process. We chose our family category and our template. We laid down our reference planes. We added constraints and parameters. We talked about work planes and building the geometry relative to those work planes. And of course, we built some geometry. And most importantly, we flexed it. So congratulations, you've created your first parametric building model or parametric model family. And in the chapters and movies that come, we will take it further and add more and more features to not only this family, but to some others as well.